What is magnetization? This is very important concept to understand the types of magnetic material. You can visit such lectures at www.apniphysics.com. Myself, Dr. Sushil Kumar. So the first supporting physical concept to explain the magnetization. One atom which have one unpaired electrons like hydrogen atom. The central part of the atom is nucleus that is represented with positive charge plus Ze. One electron is revolving around it with velocity v in anti-clockwise direction. The charge of the electron is E, mass m, and velocity v, r is radial distance. So such atoms which have one unpaired electron in outermost orbit, right, that's like the hydrogen atom, can be equivalent to a current loop, which you can see here. So now the current is flowing in clockwise direction. Here I, that is the current which is in clockwise direction. So this is the current loop. In this current loop, if you see it carefully, this one is the upper phase. So in this current loop there are two surfaces, one is upper one and second is the lower one. Here the important point, if the current is flowing into clockwise direction, the upper phase actually behave like the south pole, and obvious that lower phase will be north pole, because monopole does not exist according to the Maxwell equation. Del dot B is equal to 0. So del dot B is equal to 0 indicate that monopole does not exist. We are saying that upper phase of the current loop is south pole and lower phase is north pole. It means the atom which have one unpaired electron can be treated as a tiny bar magnet, this one. Right, so here you can see a tiny bar magnet which have south and north pole. This tiny bar magnet is equivalent to this atom. Right, this is our first concept. Now the second point, that is about magnetic dipole moment. As you know that if you keep a bar magnet in a uniform magnetic field, right, this you can see here a uniform magnetic field. Magnetic field line starts from north pole and ends towards the south pole. So in between these two poles there a bar magnet, right, it will attract towards the north pole, you can say, and this north pole will attract towards the south pole. So as a result there will be a torque, and because of that torque it will rotate. This bar magnet will rotate into this uniform magnetic field. That magnetic dipole moment, if suppose you have to find out, you can find out by this formula. P is equal to 2m into L, where m is the pole strength, where 2L is the separation between the two poles. Don't confuse these two poles with this capital one, north pole and south pole. We did not consider it. We considered 2L for this one, and pole strength of this bar magnet. Right. So concept is what here? Concept is orientation change in external magnetic field of a bar magnet. So here we have seen that orientation change of a bar magnet in the presence of external magnetic field. We know that the bar magnet is nothing that is an atom which have one unpaired electron. So if we generalize this idea for any magnetic material, you know there will be many atoms, n atoms, So each atom will behave like a bar magnet. So you can see an example of magnetic material in terms of the bar magnet. So there are some bar magnets in random direction. So these are in random direction because there is no external magnetic field. So external magnetic field is 0. The intensity of external magnetic field is 0. You can see here that this is the north pole of external magnet and south pole. In between a magnetic material is placed, right? So that magnetic material basically give the picture in terms of the bar magnets like this one. So now what we do, we apply the external magnetic field, that is the H1. H1 is the magnetic field intensity that is larger as compared to the earlier case where it was 0. So in this case we observe these bar magnet oriented in the direction of magnetic field. Right here you can see that the difference between the picture 1 and in this picture number 2. Now further, at the third case, what we are doing, we are just increasing the intensity of external magnetic field, that is H2 right now and greater than H1. Now what we have observed that almost all the bar magnet that represent the magnetic dipole oriented in a particular direction, right? That direction is along the magnetic field, right? So all the bar magnets align in a particular direction. Magnetization is what? Magnetization is basically when you place magnetic material into the external magnetic field, right? What happens? These magnetic dipoles try to align in the direction of magnetic field. Magnetization is what? Here in the first picture you can see that magnetic dipoles are oriented in a different direction. Now you apply the magnetic field. As a result, you can see here that magnetic dipole starts to align in a particular direction. When further you increase the intensity of external magnetic field, almost all the magnetic dipoles align in the specific direction. These magnetic dipoles are basically equivalent to the atom, right? Equivalent to the atoms in magnetic material. So all these are aligned in a particular direction. So you can say that this number 3 picture is more magnetized as compared to the second one, and second one is more magnetized as compared to the first one. So this is the basic idea of magnetization, right? Here so how much is intensity of magnetization? You can compare these 3 pictures and can say that the intensity in the third case is more as compared to the second one. So thanks for watching this video. If this concept or this explanation is helpful to you to make the idea of magnetization clear, please like and subscribe this video. Thanks once again.